Let's start with a question that sounds simple but isn't. What is time? Not how you measure it, not what your watch says, but what time actually is. Most of us feel we already know the answer. Time is what passes. Time is what moves forward. Time is what turns today into tomorrow. But notice something interesting. Every time we try to explain time, we explain it using something else. We say time is measured by clocks. But what is a clock? A clock is just something that moves in a regular way. A pendulum swings. A crystal vibrates. An atom flips between energy states. None of these things are time itself. They are motions we have chosen to count. So already, time is beginning to look less like a physical object and more like a bookkeeping system. Here's a simple thought experiment. Imagine a universe with absolutely nothing in it. No particles, no light, no energy, no change of any kind. Now ask yourself, would time exist in that universe? There's nothing to happen, nothing to change, nothing to compare one moment to another. So what would it even mean to say that 1 second has passed? It wouldn't mean anything at all. That should bother you a little because it suggests that time does not exist independently. It only exists when things change. In other words, time may not be a thing that causes change. It may be something we invent to describe change after it happens. Think of it this way. Imagine watching a movie reel laid out on a table. Every frame is already there. The characters don't move on the reel. Motion appears only when you play the frames in sequence. The movement isn't in the film itself. It's in the way the frames are ordered and viewed. Time might be like that. We experience life frame by frame. Our brain labels one frame as now, remembers earlier frames as past, and imagines later frames as future. But that labeling is something our brain does. It is not obviously something the universe does. Another clue comes from language. Notice how hard it is to talk about time without using metaphors. We say time flows. Time runs out. We move forward in time. But none of these statements describe something you can touch or point to. They describe a feeling. And that feeling is deeply tied to memory. You don't feel time passing when nothing changes. A boring hour feels longer than a busy one. A childhood summer feels endless, while adult years seem to vanish. If time were an objective river flowing at a fixed rate, this would make no sense. But if time is tied to how we register change, it makes perfect sense. So right at the beginning, before any advanced physics, we already see something unsettling. Time may not be a fundamental ingredient of reality like space or matter. It may be a way humans organize experience. That doesn't mean time is fake. It means it might not be what we think it is. And that's where the real mystery begins. We trust clocks because they seem objective. A clock doesn't care how you feel. It doesn't get bored or excited. It just ticks. So we assume it is revealing something deep and universal about reality. But a clock doesn't measure time itself. A clock measures motion. Every clock, no matter how advanced, is based on something repeating. A pendulum swings back and forth. A quartz crystal vibrates. An atom oscillates between energy levels. We choose one of these motions and agree to call a certain number of repetitions 1 second. That's a human decision, not a law of nature. Here's where things start to get uncomfortable. Different clocks do not always agree with each other. This isn't a philosophical argument. It's an experimental fact. If you take two identical clocks and leave one on Earth while sending the other on a fast, moving spacecraft, they will not show the same time when reunited. The moving clock will have ticked more slowly. If you place one clock on the ground and another on a mountain, the higher clock will run faster. Gravity changes the rate at which clocks tick. So which clock is correct? The surprising answer is both of them. There is no single universal time that all clocks are trying to approximate. Each clock measures time along its own path through the universe. Time depends on motion. Time depends on gravity. Time depends on where and how you exist. This destroys the old idea of a cosmic master clock, silently ticking away somewhere in the background of reality. There is no such thing. Instead, time behaves more like a flexible fabric. Stretch it by moving fast, and it slows down. Place it near massive objects, and it warps. Two people can experience different amounts of time between the same events, and neither experience is more real than the other. Think about how strange that is. Two twins can be born on the same day. One stays on Earth. The other travels near the speed of light and returns. The traveling twin is younger, not biologically by coincidence, but physically by necessity. Time has acted differently on their bodies. If time were a simple background flow, this would be impossible. The universe would have to pick one true rate of time, but it doesn't. Even more unsettling is what this means for the present moment. If time depends on motion, then now depends on motion too. What is happening now for you is not necessarily happening now for someone moving differently or standing in a different gravitational field. The idea of a single shared present breaks apart. So the clock you trust so much isn't revealing a deep truth about time itself. It's revealing how your particular path through space and motion shapes your experience of change. The clock is not lying in the sense of being wrong. It's lying in the sense that it pretends to show something universal when it's really showing something local. Time, as measured by clocks, turns out to be personal. Let's try to look at the universe in a completely different way, one that feels almost wrong at first. Imagine that the entire history of the universe is laid out all at once, not unfolding, not moving, just existing. Every event that has ever happened or will ever happen is part of a single structure. Nothing is being created moment by moment. Nothing is being erased. Now imagine this structure as something like a book. Every page represents a complete state of the universe. One page contains the formation of the first atoms. Another page contains dinosaurs walking across the earth. Another page contains you reading these words. All of the pages exist together as part of the same object. When you read a book, the story seems to unfold. But the story doesn't come into existence as you turn the pages. Page 1 does not vanish when you reach page 2. Page 3 is not waiting in the future to be created. All the pages are already there. The sense of flow comes from how you experience the book, not from the book itself. This idea sounds philosophical, but it comes directly from physics. In Einstein's theory of relativity, time is treated as a dimension, similar to space. Events are points in a four-dimensional structure called spacetime. The equations do not single out a special moment called now. Past and future appear on equal footing. There is nothing in the mathematics that says the universe must update itself moment by moment. This leads to a strange but powerful picture. The universe is not a movie being projected in real time. It is more like a completed film reel. Every frame exists. Motion appears only when the frames are viewed in sequence. So where does the present moment come from? It doesn't come from physics. It comes from us. Your brain is constantly updating information. It remembers earlier states and compares them to the current one. That process creates the feeling of a moving present. But the equations describing the universe don't include this sensation. They don't need it. This is deeply unsettling because it challenges one of our strongest intuitions, that the future is open and the past is gone. In this picture, the future is not yet real. It is just another region of the structure. That does not mean the future is predetermined in the way people often imagine. It means that determinism and free will are not questions about time flowing. They are questions about how events are related within the structure. The block universe idea does not say you are powerless or that choices are meaningless. It says that choices are events like any other. They are part of the fabric, not exceptions to it. What makes this so hard to accept is that our experience is locked to a single path through this structure. You don't experience your whole life at once. You experience one moment, then another. That sequence feels fundamental because it is how consciousness works. But feeling fundamental does not mean being fundamental. The block universe is not a claim that time is unreal in a trivial sense. It is a claim that time does not behave the way our intuition says it does. The universe may be complete, while our experience of it is not. And that gap between reality and experience is where the illusion of time may lie. If the past and the future are both part of the same structure, there is an obvious question that refuses to go away. Why does the past feel fixed and known, while the future feels open and uncertain? Physics gives an unexpected answer, and it has nothing to do with time itself. It has to do with entropy. Entropy is often described as disorder, but that's only a rough shortcut. A better way to think about entropy is the number of ways something can be arranged without changing its overall appearance. A neat deck of cards can be arranged in very few ways. A shuffled deck can be arranged in an enormous number of ways. The shuffled deck has higher entropy. The universe naturally moves from states with fewer possible arrangements to states with more possible arrangements. This isn't a rule about time flowing forward. It's a rule about probability. High entropy states are simply more likely than low entropy ones. Now here's the crucial point. Everything you associate with the passage of time depends on entropy increasing. Memory formation increases entropy. Learning, recording, thinking, even watching this video all require energy to be dissipated. That dissipation raises entropy somewhere. You remember the past because the act of remembering leaves physical traces. Neurons change. Molecules move. Heat is released. These changes only happen in one direction. You cannot form a memory of something without increasing entropy. This is why the future feels different from the past. It's not because the future doesn't exist. It's because there are no physical records of it yet. No memories, no traces, no marks left behind. A broken glass doesn't unbreak itself because there are vastly more disordered arrangements of broken glass than ordered arrangements of an intact glass. The laws of physics allow both directions, but statistics overwhelmingly favor one. So the arrow of time, the sense that time has a direction, is not written into the fundamental laws. The equations work just as well forward as backward. The direction comes from boundary conditions, from the fact that the universe started in an extremely low entropy state. That's one of the deepest mysteries in physics. We do not know why the universe began with such low entropy. We just observe that it did. Because of that special beginning, entropy has been increasing ever since, and along with it comes memory, causation aging, and the feeling of time passing. If entropy were to decrease, consciousness as we know it would be impossible. You could not form memories. You could not experience a flow from one moment to the next. You would not experience time at all. So the distinction between past and future is not fundamental to the universe. It is a feature of how information behaves within it. The past feels solid because it has left evidence. The future feels open because it has not. Time's arrow is not a river carrying the universe forward. It is a shadow cast by entropy on our experience of reality. When physicists try to look deeper than everyday experience, something very strange happens to time. As the theories become more fundamental, time starts to fade from view. In ordinary physics, time is a useful parameter. It tells us how systems change. But when we try to combine our two most successful theories, quantum mechanics and general relativity, time refuses to behave nicely. In some approaches, it disappears entirely from the fundamental equations. This is not because physicists decided to remove it. It vanishes on its own. In general relativity, time is already woven together with space. It stretches, bends, and slows depending on motion and gravity. But in attempts to describe the quantum structure of space-time itself, there is often no variable that plays the role of a universal clock. Some of the most serious equations used to describe quantum gravity do not contain time at all. They describe relationships between physical states, not how those states evolve in time. Change exists, but it is expressed as correlations, not as motion along a ticking timeline. This suggests something radical. Time may not be a fundamental ingredient of reality. It may emerge only when the universe is viewed at a coarse, large-scale level, much like temperature or pressure. Temperature feels very real. You can measure it. You can feel it. But individual atoms do not have temperature. Temperature emerges only when you average over enormous numbers of particles. In the same way, time may emerge only when you look at large systems and ignore fine details. At the deepest level, reality might be a network of relationships. One thing is related to another thing. Certain configurations correspond to what we call earlier and later. But those words are labels we impose. This helps explain why time behaves so differently from space in our experience. Space can be navigated freely. You can move left, right, up, or down. Time feels one-directional. But at the fundamental level, that difference may not exist. It may arise only when entropy and memory enter the picture. What makes this especially difficult is that physics itself relies on time to do experiments. We measure change over time, then build theories to explain it. Trying to remove time from the foundations of physics is like trying to describe a language without using words. We don't yet have a complete theory that fully explains how time emerges. There are multiple competing ideas, and none are experimentally confirmed. This is an honest gap in our understanding. What we do know is this: the deeper we look, the less time looks like a universal background, and the more it looks like a derived concept. That does not mean clocks are useless or that everyday time is an illusion in a practical sense. It means that what clocks measure may not be the deepest layer of reality. Time may be a tool our minds and our physics use to organize change, not a fundamental thread woven into the universe itself. The difficulty with understanding time may not lie in the universe at all. It may lie in the way the human brain works. Your brain did not evolve to understand space-time. It evolved to keep you alive. To do that, it needs to predict what happens next, remember what happened before, and react quickly. This naturally creates a sense of sequence. One thing leads to another, because comes before effect. This ordering feels so obvious that we mistake it for an external feature of reality. But this ordering is something your brain constructs. Conscious experience is inherently sequential. You do not experience your entire life at once. You experience one moment, then another, then another. Your awareness is like a spotlight that can illuminate only a small region at a time. That spotlight creates the impression of a moving present. Memory plays a crucial role here. Without memory, there would be no sense of past. Without anticipation, there would be no sense of future. Both are mental processes, not physical locations in the universe. They are ways your brain organizes information. This is why time feels elastic. Moments of fear feel long. Moments of joy feel short. Time seems to slow during an accident and fly during a pleasant conversation. The clock does not change its rate. Your brain does. If time were a fundamental external flow, your experience of it would be consistent. The fact that it isn't tells us something important. Time, as you experience it, is deeply tied to attention, emotion, and memory. Your brain is also a pattern recognition machine. It looks for causes and effects. If A happens before B often enough, the brain links them. Over time, this creates a powerful intuition that the past causes the future. In physics, causation is more subtle. Many fundamental laws work just as well backward as forward. The brain is not built to handle that symmetry. It needs direction to function, so it imposes one. Another limitation comes from scale. Human intuition evolved at slow speeds and weak gravitational fields. We never experience near light, speed motion, or extreme gravity, so our mental models of time are based on a narrow slice of reality. When physics shows us that time stretches, slows, and depends on motion, it clashes with intuition, because intuition was never trained for that world. We also confuse description with explanation. Saying something happens because time passed feels like an explanation, but it isn't. Time is often just a label for change we don't fully understand. The brain accepts this shortcut because it's useful. All of this means that the feeling of time flowing may be less like a window onto reality and more like a user interface. It is a simplified display that helps you function, not a faithful representation of what exists underneath. This does not make your experience unreal or unimportant. It makes it limited. Understanding time may require accepting that our deepest intuitions were never designed to tell us how the universe truly works. They were designed to help us survive within it. If time is not a universal flowing thing, if it does not exist as a fundamental background of reality, then what does that say about the world you live in and your place within it? It says something subtle, not dramatic. It says that reality is not organized the way human intuition expects. Change is real. Events are real. Physical processes happen. None of this disappears when we question time. What disappears is the idea of a single cosmic clock pushing everything forward. The universe does not appear to be becoming moment by moment. According to our best theories, it simply exists as a whole. The laws of physics describe relationships between events, not a command that tells the universe to update itself every second. This does not make life meaningless or mechanical. It makes it deeply structured. You are not racing against an invisible river that is dragging everything away from you. The moments of your life are not being destroyed as soon as they occur. In a very real physical sense, they are part of the structure of the universe, just as real as any other moment. What changes is not reality itself, but your access to it. You experience one slice at a time because that is how consciousness works. Memory gives weight to earlier slices. Expectation gives shape to later ones. The feeling of movement through time is the result of that process, not evidence of a universal flow. This perspective quietly changes how you see existence. The present moment stops being a fragile point balanced between a vanished past and a non-existent future. It becomes a location within a larger structure, not privileged by physics, but special to you because you are there. Science does not tell us why the universe exists or why it has this structure rather than another. It does tell us that the universe is stranger than our everyday stories about it. Time, which feels so obvious and so dominant, may be a secondary concept, arising from deeper, timeless laws. That realization carries a kind of intellectual humility. It reminds us that human intuition is not the final judge of reality. Our experience is real, but it is not the whole picture. Physics does not remove mystery. It sharpens it. When you look at the night sky, you are not seeing light that used to exist and is now gone. You are interacting with other parts of the same structure you inhabit. Different regions, different conditions, but the same universe. Time, in this view, is not an enemy or a resource that runs out. It is a way we describe our journey through a reality that is far larger than our experience of it. The universe is not rushing anywhere, and neither, in a fundamental sense, are you.